Okay, I want us to prove midpoint theorem that states that the line the line drawn joining the midpoints of two sides of the triangle is parallel to one side and it's parallel to the third side, not one side, it's parallel to the third side, parallel to the third side, and it's half the third side. So it's called the midpoint theorem. So the line drawn parallel joining midpoints of the two sides of the triangle is parallel to the third side, and it's a half that. In other words, let's say we have a triangle here. Let's have a triangle A, B, C. Let's have a D here as a midpoint, meaning that this is equal to this, and let's have a D, E, saying that this is equal to this. This is what we want to do. So our RTP here is to prove that DE is parallel to BC, and BC is equal to 2 times DE, or DE is equal to 1 over 2 BC. That's RTP. So now to prove that, we must bring up the construction. So our construction is extend DE to F such that our DE is equals to EF, and join FC. So I'm going to have extension here, and then have F here and join here. Make sure that this it is equals to that. That's what we are doing here. So this is my, so now I want to prove. If you look at this now, because I've done, you can see I have initially I had this bigger triangle and a smaller triangle. Now I have two smaller triangles. So let me call this one E1. This is E2 here. I'm going to say in triangle ADE and triangle EFC. What do I see here? I can see that in these two triangles, I can see that I have my DE being equals to FE. This is by construction. I have my AE being equals to AC. This is given that the line drawn joining the midpoint, so is the midpoint. Then I can say that E1 is equals to E2. Those are vertical opposite angles. With that given, I can say triangle ADE is congruent to triangle EFC. If these two triangles are congruent and this side is equal to this one is equal to that, I can simply say that this angle is equal to this, then angle A is equal to angle C, then in this case angle ADE is equal to angle EF or angle EFC. That is because of congruent triangles. If like this, if this angle is equal to this angle, I can say that now these angles, they are what? They are alternating. Those angles are alternating. Therefore, I can say that DA is parallel to FC. Okay, I can say that. Even from that, now I can even say that BD is parallel to FC, and now that is parallel because of the alternating angles, because of a angle ADE equals to AFC. Now what do I know? I know that I can even say DA is equals to FC. This is bicongruent triangles. Therefore, I can say that now figure, I can say that from there, I can say, let me take it to this side. I can say figure DFCB is a it's a parallelogram. Why would I say that? Because BD is parallel to FC and BD is equals to FC. So opposite sides are equal and parallel. Now if that's a palm, also that makes it to say DF is parallel to BC. That are opposite sides of a palm. Opposite sides of a palm. Opposite sides of a palm. Oh, let me write it nicely. Opposite sides of a palm. Opposite sides of a palm. And again, I can say that BC is equals to DF. Again, these are the opposite sides of a palm. Now, what do I know? I know that now DF is equals to 2 DE is equals to 2 DE. Therefore, BC is equals to 2 DE. Then I've proved that the lines are parallel. Here I've bring that they are parallel, and the other one is half of the other.